And good morning, math wizards. It's time for another edition of Mr. Leggett's Math in the Morning. This is Eureka Math in the Morning. And what does Eureka translate when translated into the English language? It means I have found it. And what have we found? We have found the best way to learn math, and that is more valuable than gold. And I say that because the miners of California allegedly, or supposedly, screamed Eureka when they would find a big chunk of gold. Let's find out our objective today. We're going to apply the distributive property to find the total area of a large rectangle by adding two products. A lot going on here. First thing we're going to do is find the unknown factor. How do we find the unknown factor? Well, we can do it like this. And let's start off with 4 times a blank equals 12. All right? So that's what we have going on. I got to center my camera here. I'm way off. I'll move this over a little bit. Nope, wrong way. There we go. What happened? All right, so 4 times what equals 12? Well, let's count by 4s. 4, 8, 12. So it's 4 times 3. And let's take a look at 6 times a number equals 12. Well, 4 times 3 is 12, and 6 times what would be 12? Well, if we count by 6s, or go 6 times 1 is 6, 6 times 2 is 12. And we could say 2 times a number equals 12. What's with all these 12s? All right, so 2 times what is 12? We see how we can flip these around, or well, not yet. 2 times what is going to equal 12? 2, 4, 6, 8, 10, and 12. So 2 times 6 equals 12. So 6 times 2 equals 12. You get 2 times 6 equals 12. It doesn't matter. Let's go back up to the top here. See the top here? See what we're talking about? 4 times 3, and we're going to do 3 times a number equals 12. Well, 4 times 3 is 12. 3 times what's going to be 12? Well, we can just automatically know it's 4, but let's prove it. 3, 6, 9, 12. 3 times 4 is 12. Let's try one more before we move on to our worksheet. 8 times a number equals 24. So let's think about this. 8 times what would equal 24? I know 8 times 1 is 8. 8 times 2 is 16. 8 times 3 equals 24. Okay, go ahead and grab your sheet of paper with all these math sentences on it. And we're going to fill these out. I want you to fill these out on your own. Just go like this. 6 times the number equals 24. You can find 24 on your multiplication chart and see that it'd be 6 times 4. You should find all of these on your multiplication chart except this one. Let's go over here. 3 times a number equals 72. Let's think about that. Let's go down here. We could say 3 times 10 equals what? Well, it equals 30. 3 times 10 equals 30. So now we're at 60. 60 is only 12 away from 72. So 3 times a number equals 12. Okay, what would that number be? We've already done this. 3 times 4. So then we could see, let's just add these up to see what it is. 2, 3, 6, 72. It is 72. So 3 times 10, 24 is 72. Okay, you should be able to do all the rest on your own. Please pause the video and then come on back. And welcome back. You're done with your multiplication, so just go ahead and take that multiplication right now and put it in the blue bin, okay? Let's get to our application problem. It's just on the other side. Mine's the original, so. And we'll find out what we know. Well, Sonia folds a 6-inch by 6-inch piece of paper into 4 equal parts. So it's 6 inches by 6 inches, 4 equal parts. What is the area of one of the parts? Just one of the parts. Interesting. So let's make a model of this to start out so we can figure this out. Okay? We'll make a nice model and go from there. Here's Sonia's piece of paper. To start with. She folds it into 4 pieces. There's the first fold. Here's the second fold. Before she folded it, remember it was 6 inches by 6 inches by 6 inches by 6 inches. So there's her piece of paper. 6 inches, 6 inches, 6 inches, 6 inches. If we did perimeter, it would be 24 inches, correct? Yes, it would be. Did somebody say perimeter? Oh, mathmud, it's another P word. I know how much you like to say P words. Yes, like parentheses. But I also like saying perimeter. And can you remind us what perimeter is? Yes, perimeter is simply the length around this shape. So around Sonia's square, it would be 6 plus 6 plus 6 plus 6. Yes, it would be. And what would that be? Well, instead of adding 6 plus 6 plus 6 plus 6, I could just do 6 times 4 because there's 4 sides. And 6 times 4, as we all know, is 6, 12, 18. It's a 24. Yeah, it is. That's the perimeter. Yes, Mr. Leggett. All right, Mathmut, you can come back later on, all right? Because I've got to teach some more stuff about area. Oh, I like the area too. Maybe I can come back and help. Yes, maybe you can. Oh, thank you, Mr. Leggett. All right, Mathmut, thank you for joining us. All right, so now that we folded it in half, though, let's relabel it. And they're all the same length, 6 inches, right? So what's half of 6? It's 3 inches, right? So let's put 3 inches, 3 inches, 3 inches, and 3 inches. So we're just looking, well, that's a bad one, Mr. Leggett, 3 inches. So we're just looking for the area of one of these parts. So all we want to do is find one of these parts, okay? I'm going to circle on that one. So now we can clearly see that to get the area, we multiply 3 times 3. 3 times 3 equals what? 3, 6, 9. 9. So the area of one part, remember we read, we drew, and now we're writing, is 9 square inches. All right, that's the area of one part is 9 square inches because we did 3 times 3. We weren't looking for the whole part, we were looking for just that one section, okay? Now let's take a look at the area of the whole piece of paper. What would we multiply to get the whole area of the entire piece of paper before we folded it? Well, if we had 6 and 6, well, yeah, that's all we would multiply, 6 times 6. So let's go 6 times 6. What does 6 times 6 equal? Let's skip count. 6, 12, 18, 24, 30, 36. So we could say the area of the piece of paper, the whole piece, that's an E, is 36, what kind of inches? Square, man. Square inches, period. So there we have it. And then we could also say, if we wanted to, we could take a look and kind of reverse it to double check, and we could say 36 divided by 4 is equal to 9. 9, 18, 27, 36. So we know that everything is correct. Alrighty? Okay, let's put this away. Keep this for homework tonight. We might need it. And please, in your problem set, you're going to tear out this page right here. And this is page 93. All right? Page 93. Let's take a look at the large rectangle. Let's trace its boundaries with our finger. Okay, the shaded rectangle and the unshaded rectangle. So let's do that again. Shaded, unshaded. Oh, Mr. Leggett, can I do that too? It looks like much fun. Well, you could, Mathmut, but I think your head's too big. You're probably right. I'll use pin. Shaded, unshaded. Oh, very good, Mathmut. Thank you for helping. You're welcome. So we have the shaded and unshaded. Let's get busy and start measuring with our rulers. If you don't have a ruler in your desk, if I've taken it away because you made helicopters out of it, go get one now. And let's take a look. Let's measure this top right here. Okay, this is in millimeters. My ruler is in millimeters. Let me see if I can get one with just centimeters so you can really see it, and I'll make sure we have plenty of centimeter rulers. So I don't want anyone getting confused by all of these millimeters. Oh, here we go. This one is in centimeters. So I'm going to measure this one, and I'll see at the top here it is lining up. It is 6 centimeters. So we're going to label this 6 centimeters. Now let's label this 5. Oh, I've used the inches side, don't you know? Okay, so we're going to go here, and this looks like it is 5 centimeters. Now let's measure the unshaded one, okay? See what it's all about, okay? Okay, we're going to do the side. That's all we really need to do, isn't it? Because we already know the length here, right? It's 6 centimeters, so this is 3 centimeters. And we're ready to figure out the entire area of the shape. Let's see what it's all about. How could we do this? Well, we could break this down. Let's worry about this guy first, okay? And it's 5 times 6, right? That's going to give us the area of the shaded rectangle. So we'll do 5 times 6. And then this one is going to be 3 times, we know what that is, right? It's 6. So 3 times 6. So we have 5 times 6 and 3 times 6. But to get the area of the whole rectangle, we're going to have to do some multiplication and then some addition. So let's get right on that. I shouldn't have written page 93 there. Crazy old me. So let's get going on this, and we'll say that 5 times 6 plus 3 times 6. This will give us the area of the entire rectangle. Now, what is 5 times 6? 5, 10, 15, 20, 25, 30. So this equals 30 plus 3 times 6. 3, 6, 9, 12, 15, 18. 30 plus 18. Now, you should be able to do this in your head. 30 plus 10 is 40, and 40 plus 8 is 48. So we have 48. Are we done yet? No, we need to do a little bit of writing too. So we can say the rectangle in its entirety has an area of 48 square centimeters. So the area of that is 48 square centimeters. Alrighty, go and pause that if you need to write all that down, because in Eureka Math we read, draw, and write. Alrighty, let's go ahead and flip this puppy over. And watch this. Here's something kind of fun to do about the distributive property. Let's say we had a rectangle. I'll go ahead and draw this on the back. I'm going to get a clean piece of paper, just so you don't see the bleed through, but yours should be fine. Let's say we have 8 times 6. No, let's go a little further. Let's say we had a rectangle that was 8 units by 6. Okay, we could do 8 times 6, but we could also do something like this, couldn't we? 8 times 6. And I could go 5 plus 3 times 6. Isn't that the same thing? 5 times 3 is 8 times 6. 8 times 6. And then we could break it down to 5 times 6 plus 3 times 6. Kind of like what we did. 30 plus 18. 5 times 6. 5, 10, 15, 20, 25, 30. So 30 plus 3 times 6. 3, 6, 9, 12, 15, 18. And that would equal 48. 48 units. So distributive property in action. Kind of just redid it for you. Why not? All right. Time for problem set time. Yeehaw! Problem set. We're going to go to page 91. Today's date will be tomorrow, 03/12/2020. Okay, I'm going to zoom in a little bit and get a better picture of our problem set. Better not keep saying these P words. Our Mr. Math Mutt might come out. And we'll zoom in, just tighten it up just a little bit. Just tighten it up just a tad. Okay, there we go. So, I'm going to make a little mark right there and a mark right there just to keep my frame centered. All right, let's read our instructions. It says, label the side lengths, that's something we need to do, of the shaded and unshaded rectangles when needed. Then, find the total area of the large rectangle by adding the areas of the two smaller rectangles. So remember what we did recently, like just a few moments ago. We ran our fingers across and went shaded, unshaded, right? So let's figure what this is all about. It's already been labeled for us. It's 5, 7, and 3. So I know this is 7. So it's a total of 5 plus 3 is 8. 8 times 7 equals 5 plus 3 times 7, or 5 times 7 plus 3 times 7. Look, 5 times 7, 3 times 7. What is 5 times 7? 5, 10, 15, 20, 25, 30, 35. So it would equal 35 plus 3 times 7. 3, 6, 9, 12, 15, 18, 21. And then you could add up 35 and 21. You can do that in your head, but I'm showing you this way. 5 plus 1 is 6, and 3 plus 2 is 56. So it's an area of 56 square units. So this one, the shaded, had 35, and the unshaded had 21. Don't believe me? You can pause this and count. All right, let's see what we got going over here with those tricksters at Eureka are all about. First of all, we need to figure out all of the, we need to label the side lengths, okay? So we have 1, 2, 3. 1, 2, 3, 4 has been labeled for us. We have 2 here. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So we'd have 10 right here. Kind of a different shade there. Kind of threw me off. I'm like, what are they doing? So 12 times 4. How do we know it's 12? 10 plus 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times 4 equals 10 plus 2 times 4. Or we could break this up a little bit and do 10 times 4 and 2 times 4. Look at that. Look at that. What's 10 times 4? We know it's 40. 10, 20, 30, 40. 40 plus 8, 48. Our area is 48 square units. Making sense? I hope so. Looks like we got to do some more serious labeling going on here. We have 6 here, but we have to figure out what's it across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3. And I know this side is 6 already. So we have 6 times 13, 10 plus 3, equals 6 times 10 plus 3, or equals 6 times 10 plus 6 times 3. What's 6 times 10? 10, 20, 30, 40, 50, 60. Plus 6 times 3. What's 6 times 3? 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. What's 60 plus 18? 6 plus 1 is 7. 0 plus 8 is 8, right? So our area is 78 square units. All right, we got to label both sides now. Wow, what are they thinking? Let's doing all this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2. So this side's going to be 12. Let's see what this is. 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 12, right? 8 times 12 to figure out the area would equal 8 times 10 plus 2, right? That would equal 8 times 10 plus 8 times 2. See how easy this makes it? 8 times 10, 80. 8 times 2, 16. What's 80 plus 16? 8 plus 1 is 9. 0 plus 6 is 6. Our area is 96 square units. How do you like that? Turn the page over. Turn it back once so you can get a good look at it. And let's turn it over and figure out what's going on here. Number 2 says Vince imagines one more row of 8 to find the total area of 9 times 8 rectangle. So he's imagining one more of 8. Explain how this could help him solve 9 times 8. That's a lot going on with that question right there, I'll tell you that much. So, let's think about it. So let's just take a look at the labels here, because this is a confusing question. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that one, 10. So we have 1 here and 9 there, and then 1, 2, 3, 4, 5, 6, 7, 8. All right, so this is the one he's imagining. Why would he imagine that? He's solving 9 times 8, right? And if we didn't know 9 times 8 off the top of our head, we could say that, okay, Vince, we'll say this can help Vince solve 9 times 8 because now he can, listen to this, think of it as 10 times 8. All right, so now he's thinking of it as 10 times 8 instead of 9 times 8. All right, now he could just go, 10 times 8, Vince can now subtract 8, 1, 2, 3, 4, 5, 6, 7, 8 from 80. That equals what? 72. Alrighty. Let's go on to our next problem. You can pause that to catch up if you need to. And this says, break the 15 by 5 rectangle, this is 15 by 5, into 2 rectangles by shading one smaller rectangle within it. Then find the sum of the area of the 2 smaller rectangles and show how it relates to the total area. Explain your thinking. Boy, that's a lot going on. So let's take a look at this, and I think the easy way to break this up would be to go like this. 1, 2, 3, 4, 5. Just draw a 5 across there and shade it in. So now we could label it, right? We can label it 10 by 5 by 5. You see that? 10 by 5 by 5. Let's do the math. 15 times 5. What does it equal? It equals 10 plus 5 times 5. 10 plus 5 times 5. Okay, that will equal what? 10 times 5 plus 5 times 5. And that will equal 50, right? Plus 5, 10, 15, 20, 25. Plus 25. And what's 50 plus 25? Oh, not 27. Oh, that came out. So 50 plus 25, then if you had 2 quarters and you had another quarter on, money-wise, 50 cents plus 25 cents, that'd be 3 quarters or 75. Okay, so now we can explain our thinking of how we broke this apart. We can say the total area is 75 square units. I broke apart 15 to 10 and 5. Because they are easy to multiply. Period. So that's what we're going to do. Oh, wait a second. Mr. Math Mutt is coming this way. Here he comes galloping. He goes, oh, Mr. Leggett, I'm sorry I missed most of the math lesson. Well, you got the most important part, right? You got those perimeters and you got some other things. Yes, I did. And I'm pretty good with area. Yes, you are. Yes, you are. Do you have a joke for us today? Yes, I do. I was walking down the street and the man said, I haven't had a bite in 3 days. So what did you do? I bit him. Thank you, Math Mutt. It's a great joke. We'll see you tomorrow, hopefully. Mel, 4th grade, we'll see you tomorrow. Have a great rest of the day, Math Mutt. All right, boys and girls, thank you for being such a great audience. Bye-bye.